Today we're looking at function composition, which is what happens when we take two or more functions and combine them in a way that does one first and then the other. So the idea here is that first we do evaluate one function and then take the result of that and plug it into the sort of next one. So I'm going to take these two functions. Suppose f of x is this and g of x is that. Find each of the following composite functions and simplify. So the way you read this notation in the little circle is the composition operator. You read that like of. So this means f of g of x, or in other words, if we want to write it in a way that maybe looks a little more familiar using our function notation, I could write it as f of g of x. Now what this means is that I'm first going to consider g and then plug g into f. In other words, here's g. Wherever x appears in the function representation for f, I'm going to replace it with g. So this is, I'll write it here, f of g is 2x plus 1. So what I'm going to do is write out a thing that looks like f squared minus 2 plus 3. But everywhere that the variable showed up initially, I'm going to replace with 2x plus 1. This is the composite function. This is g of f written in terms of x. Again, that's all the of x part means. So this is our composed function that first does whatever g does and then takes that result and plugs it into f and does whatever f does. This is it. What is left then is to simplify. So I'm going to start simplifying this. Erase some of this stuff. I'm going to start simplifying this. Here we need to square the quantity 2x plus 1. That's 4x squared from 2x times itself. Then the outer and inner parts of the product, 2x times 1, and that happens twice, so plus 2x, and then 1 times 1, so plus 1. And again, if you need to, go out to the side or something and remind yourself that what squaring means is that. And so you distribute everything and you end up with this. Here we've got a 2 to distribute, so negative 2 times 2x, negative 2 times 1, and then plus 3. And now that everything's expanded, I'm just going to look for like terms. There's only the one square term. 2x plus 2x minus 4x, so 2 plus 2 is 4 minus 4, so those actually add out. We have no linear term then. And then plus 1 minus 2 plus 3. So 1 minus 2 is negative 1, plus 3 is 2. So 4x squared plus 2 is this composite function completely simplified and combined. Now would want to be one of those really good times to pause the video for a second and try this one on your own. We're going to do exactly the same thing, but in reverse order because the order is reversed here. So this is g of f of x, where f of x is this. So again, if you want to take a second, pause things, work through this on your own, and then come back. Okay, here we go. So g of f of x, or g of, that's not going to be enough room, silly goose, x squared minus 2x plus 3. So a thing that looks like g, but in place of x, I put f. That's the composite function then. everything that happens after this is just simplifying. I've got 2 times the quantity, so I'm going to distribute 2x squared minus 4x plus 6 plus 1, 2x squared minus 4x plus 7. So there's your simplified composite function. And just one more time, important to notice that these are different. These were the same 2 functions that we're composing. All we did is switch the order we composed them in, because we got different things there that, again, really underlines the fact that the order is important here. They don't necessarily work in the same order, or sorry, work the same in reverse order. Okay, I hope that is helpful.